How are you, my friends? This is lecture 26 of the pre-calculus course, Advanced Trigonometric Equations. This lecture 26 is related to lecture 25, please. 25, it was the basic trigonometric equations if you want to see more simple questions than these here. So in this one here, we solved advanced trigonometric equations. I put here some ideas to help you. We can use trigonometric identities, the sum and the difference. So this is lecture 21 and 22. There are some formulas there. We can use trigonometric identities, double and half angle in lectures 23, 24. And also, as I mentioned before, the basic trigonometric equations were mentioned in lecture 25. So let's start directly with examples. Example number 1. Solve the trigonometric equation 2 sine squared of x plus 3 cosine of x is equal to 3. Clearly, we can see here that we have two functions in the same equation. So it's a good idea that we can make the same function so that we can factor it. So let's rearrange this equation. This is the given. Remember here, 2 sine squared of x plus 3 cosine of x is equal to 3. It's easier to change sine of x into cosine because we have a squared there. And we know this trigonometric identity, sine squared of x is equal 1 minus cosine squared of x. So I replace that in here. See, I put it inside the bracket. 2 times 1 is 2. 2 times cosine squared of x minus 2 cosine squared of x plus the other part. Bring 3 on the other side is equal to 0. Let's add here 2 and minus 3 will be here minus 1. Since the leading coefficient here is minus, let's multiply by minus 1 to make it easy in the factoring. So it will be 2 cosine squared of x minus 3 cosine of x plus 1. So now this is easy to factor. We continue the solution on the next slide. So this is the equation we had. Let y equals cosine of x, just to make it easy on the factoring. So this becomes 2y squared minus 3y plus 1. So we can factor it as 2y minus 1, y minus 1. If you multiply these, you would get this equation. So now we can replace back. Instead of y, we put here 2 cosine of x minus 1 equals cosine of x minus 1. You can directly factor from here. See, from the first line, you can directly factor this. But this is an easy way if you have any difficulty in factoring. So now we have here cosine of x is equal to half, or cosine of x is equal to 1. So here we need to find all the angles where the cosine is half, or here where the cosine is 1. So from the last slide we see cosine of x is equal to half, or cosine of x is equal to 1. Let's take this one on the right side here. This is easy because cosine of x is equal to 1. This angle lies on the x-axis and this angle is 0. Cosine of the 0 is 1. Now, if we look at the first one, cosine of x is equal to half, we have to check the quadrants, remember. So we look at the sign here, positive. See, half means positive half. So this is quadrant 1 and 4, where cosine is positive. Now, what is the reference angle? Because the cosine is half, the angle in the reference angle is pi over 3. So let's go now to quadrant 1 and quadrant 4 and find all the angles. In quadrant 1, the angle is the same as the reference. In quadrant 4, if we know the reference, then the angle will be 2 pi minus the reference. So 2 pi minus pi over 3. Find the LCD there. That will be 6 minus 1, 5 pi over 3. See, in example number 1, you can see there See, there is no condition here. Nothing like 0 to 2 pi, 0 to pi, whatever. So we have to find a general solution. So when we found all these angles in the period of the cosine, we have to add 2k pi. So the all solutions or the final solution or the general solution will be pi over 3 plus 2k pi, 5 pi over 3 plus 2k pi, and 0 plus 2k pi from this angle here. Now let's look at example 2, which is very important. In the next slide, I will tell you why it's very important. Let's find the number of the solutions of the trigonometric equation. Cosine of theta plus 1 equals sine of theta in the interval 0 to 2 pi. So we have to look for all the angles theta that will satisfy this equation in this interval. Now we see in the equation here, there is no squared in the sine squared or cosine squared, so we cannot use any trigonometric identity. So it's a nice idea to square both sides. So cosine of theta plus 1 all squared is equal to sine of theta all squared. Now remember, when you square both sides, you have to check all the proposed solutions at the end in the original equation. So that's why this equation is very important. Cosine of theta plus 1, remember the formula from algebra, a plus b all squared. It will be a squared plus 2ab plus b squared. We can apply that here on the left side. Is equal to sine squared of theta. Now looking at the equation, we have two functions there, so we can replace the sine squared of theta by 1 minus cosine squared of theta to make it easy on factoring. So I replace on the right side here 1 minus cosine squared of theta. Then take this on the other side, becomes 2 cosine squared of theta, cancel the 1, and then we divide by 2 to make it more and more simple. Now to factor cosine squared of theta plus cosine of theta is equal to 0, the only way we can do that is by common factor cosine of theta times cosine of theta plus 1. So this will be cosine of theta is equal to 0 or cosine of theta is equal to minus 1. Now we will look at the angles. Which angles in this given condition from 0 to 2 pi will make the cosine of theta is equal to 0? Theta will be here pi over 2 and theta will be 3 pi over 2. Cosine of theta is equal to minus 1, theta will be pi. So we have three proposed solutions to check. We have to check all of these. So I replace pi over 2 in the original equation here, you see. Then I get 1 is equal to 1, which is correct. Then I replace 3 pi over 2. I get 1 is equal to minus 1, easy to check. This is not acceptable, rejected. Cosine of pi, the third one, plus 1 is equal to sine of pi, yes. Minus 1 plus 1 is equal to 0. So the solutions are pi over 2 and pi. So if we ask what are the number of solutions, the number of solutions is 2. Now example 3, we have a new idea here inside. Find all the points of intersection of the graphs of the two functions f of x, sine of x, and g of x is equal to cosine of x in the interval 0 to 2 pi. Now you can do this by graphing both functions together, and you will look and see the points of intersection. The points means you have to find the x and the y values. But this is not easy when you look at the graphs. Let me show you an algebraic way, which we may have mentioned before. So we have the two functions here, f of x is equal to sine of x and g of x is equal to cosine of x. I can put f of x is equal to g of x, which means y equals y. Then I have to find the x value. So I put now from this, sine of x is equal to cosine of x. To make this equation easy, I can divide by cosine of x. Then I will have tan of x is equal to 1. Now remember here, I can divide by cosine of x because I'm not losing any solution. So here we have to look for all the values of x in this interval minus pi over 2 to pi over 2. So what are these x? X will be pi over 4 plus k pi because the period of tan is pi, remember. So let's use this equation to find the x values. So this is the equation we got from the solution. X equals pi over 4 plus k pi. Let's find all the solutions in this interval from 0 to 2 pi. So I can replace k by, you remember k is integer here. So k can be minus 1, minus 2, minus 3, 0, 1, 2, 3, 4, etc. So if k is equal to 0, then x will be pi over 4. Is it there, pi over 4? Yes. If k is equal to 1, so pi over 4 plus pi, it will be 5 pi over 4. If k is 2, so it will be pi over 4 plus 2 pi, which is greater than 2 pi. Or if you take here k minus 1, it will be minus also, not in this interval. So what are all the values of x in this interval? Only when k is equal to 0, k is equal to 1. Now, this is x value. That means 2 points. If x is pi over 4, then I have to find y. I can use either function f or g. It's up to you. You will get the same value. See here, I use the sine pi over 4. You can use also the cosine because these points are common in the points of intersection of the two graphs. X equals 5 pi over 4. You can say also sine 5 pi over 4 or cosine 5 pi over 4. You will get the same answer. So now this is x, this is y. That's 1 point. This is x and this is y. Now I will show you the graph here as an extra stuff here you can see. Now this is the answer here, please. Pi over 4, square root of 2 over 2. This is point A. See, this is point A in the intersection. Another point B, 5 pi over 4, and the y minus square root of 2 over 2. The sign of the x here, the graph, is the black, and the red one is the cosine. So the intersection here at pi over 4 and 5 pi over 4. Here the y is positive, and here the y is negative. So these are the points of intersection here, A and B. Now let's remember from lecture 25 something nice. If we have 2 sine of x minus 1 is equal to 0, then sine of x will be half. So how to find the solution? We look at the sign here, the plus half. It can be minus half in other questions. Plus, so I go to quadrant 1 here, and plus, it will be sine in quadrant 2 also. So we write the general solution, pi over 6 plus 2k pi for this equation, simple equation here. And then x will be 5 pi over 6. From where we get this one? From, this is the reference, pi over 6. So it will be pi minus pi over 6, which will be 5 pi over 6 plus 2k pi. You can review, please, if you want, lecture 25. So these are basic equations. Now, what will happen here, the next example, this x here, we will make it multiple angles, half angles, etc. So instead of this x, I will put 3 theta, 4 theta, 5 theta, theta over 2, etc. So it will be more advanced. But we use the same idea. Let's see the question. Given the trigonometric equation, 2 sine of 3 theta minus 1 is equal to 0. Let's find all the solutions without any condition. In the B part, let's find the solution set. Find all the solutions in the interval 0 to pi. Now, anytime you see double angle, half angle in the equation here, so you can make it simple and say let. 3 theta or whatever the expression here, let 3 theta is equal to x. Make it simple. But remember here, we need the values of the theta, not the values of the x. So let 3 theta is equal to x. So the whole equation now becomes sine of x is equal half, you see? This is x, take one on the other side, divide by 2, which is exactly what we did in lecture 25. So let's continue. So sine of x is equal to half. We asked the questions, which quadrants? So this will be quadrant 1, quadrant, and quadrant 2. So x will be pi over 6 plus 2k pi, and x will be 5 pi over 6 plus 2k pi. Remember, x now, each x is 3 theta. So I can replace this x here by 3 theta, the same expression there. X will be 3 theta. Remember, we need theta, the equation, the given equation, the equation here in example 4, find all the values of theta. So let's divide by 3. All the equations here, divide by 3. So it becomes theta. Divide by 3, pi over 18. Divide by 3, 2k pi over 3. Divide by 3, 5 pi over 18 plus 2k pi over 3, where k is integer. These are the general solutions of theta. Very important to review this. Now let's see. This is from the last slide here, the thetas. K is integer. We need now all the solutions in 0 to pi. We know the story. We have to replace k is integer. So I can take any integer. K is equal to 0. I have to try. K equals 0, 1, minus 1, until I get all the values from 0 to pi. So if I put k equals 0, it will be pi over 18. See here, put 0 there, it will be pi over 18. Put 0 there, it will be 5 pi over 18. Now, if k is equal to 1, we replace in the first theta here, pi over 18 plus 2 pi over 3, we multiply up and down by 6, because the LCD will be 18. So we get 13 pi over 18. In the second one, we replace k by 1. We get 5 pi over 18 plus 2 pi over 3. Multiply up and down by 6. You will get 17 pi over 18. Now, just little remark here. If you take k less than 0 or k greater than or equal to 2, which means not 0, not 1, the theta you will get will be outside this interval from 0 to pi, so they are rejected. Now, the solution set, only 4 values of theta, pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, which is the answer. Now, in case they will ask about the sum of the solutions in this interval 0 to pi, just add these 4 values of theta, and then the answer will be 2 pi, just in case they ask about the sum. Let's see the next slide, please. In the next slide, I will show you another way to find these values of k. Let's see here. This is the thetas from the previous slide. Now we have 0 to pi. So let's create an inequality of this theta between 0 closed, because that's closed here, equal, less than pi open. And then this is compound inequality. I will try to solve for k, which is so easy now. Multiply by 18, subtract here pi from each side, and then divide by 12 pi. You will get k between 0 and 1. So in this case, k will be 0 and k will be 1. Also, the same thing for the second theta, 5 pi over 18 plus 2 pi k over 3 between 0 closed and pi open. I simplify here and solve the inequality. I will get k between 0 and 1 point something. I need integers, remember? So k will be 0 and 1. That's another way. Now, after that, you take k equals 0, k equals 1. You replace them here, and then you find the solution as expected. Example number 5, given the equation square root of 3 tan theta over 2 minus 1 is equal to 0, find all the solutions without any condition Second part, find the sum of the solutions in the interval 0 to 4 pi. Now remember here to use the idea of x. Let theta over 2 is equal to x to make the equation simple. Now let's rearrange the equation. This becomes square root of 3 tan of x equals 1. Take 1 on the other side. So tan of x will be 1 over square root of 3. Now remember, we have to find all the angles in this basic period between minus pi over 2 to pi over 2. So x will be pi over 6, which is the 30 degrees, plus k pi, because the period of the tan is pi. So this is x, remember. But in the question, we have theta. Every x is theta over 2. So I can replace this x by theta over 2 equals pi over 6 plus k pi. I need theta, so multiply by 2 on both sides to get theta. Multiply by 2, multiply by 2, multiply by 2. So the solutions are pi over 3 plus 2k pi, where k is integer. This is the general solution. Now in the second part, we need from 0, look at the condition here, from 0 to 4 pi, I need all the solutions. Let's see how can we do that. We can replace starting k equals to 0. Then this will be k0 here because k is integer. So theta will be pi over 3. If k is 1, it will be pi over 3 plus 2 pi, 7 pi over 3. Let's take k2. You can take any integer there, but remember the condition. If you take k equals to 2, theta will be 13 pi over 3 because pi over 3 plus 4 pi. So this will be more than 4 pi. So this is rejected. And for sure, every k after that will be rejected. So the solutions will be pi over 3, 7 pi over 3. Let's find the sum, 8 pi over 3. Solve the trigonometric equation. Cosecant squared of x minus 1 is equal to 3 cotan squared of x plus 2. You can take a minute here and try it, please. Then you can see the next slide for solution. The idea here, we did it before, we have two different functions in the same equation. We try to make the same function so that we can factor it easily. So what can we do? We know 1 plus cotan squared of x is equal to cosecant squared. So instead of this cosecant squared, see on the left side here, cosecant squared, in the bracket here, I will put 1 plus cotan squared of x minus 1, you see that one, equals 3 cotan squared of x plus 2. Let's rearrange the equation. We can cancel 1 and minus 1, that will be 0. Cotan squared of x is equal to 3 cotan squared of x plus 2. Take 3 cotan squared on the other side, becomes minus 2 cotan squared of x is equal to 2. Divide by minus 2 to make the equation the simplest form, which would be cotan squared of x equals minus 1. And here we have to think. If we take the square root of both sides, we get cotan of x plus or minus the square root of minus 1. And this one is rejected because the square root of minus 1 is complex. Or we can see another reason. This is squared. You see cotan of x all squared. So that's positive side. Cannot be equal to a negative side. Then we say no solution for the equation in example 6. Example 7, solve the inverse trigonometric equation. Cosine inverse of x plus tan inverse 5 over 12 minus pi over 2 is equal to 0. Let's find the value for x. Now look at the idea here. I put a nice idea here. Anytime you have an inverse in the equation, isolate the term with x and take cosine of both sides, because we have here cosine inverse with the x. If we have sine inverse, so we isolate the term with the x and we take sine of both sides. If this is tan inverse of x, we take tan of both sides. See, this is the idea here. This is the key point. So let's take cosine inverse of x is equal to pi over 2, take everything on the other side, minus tan inverse 5 over 12. Take cosine of this side, take cosine of this side. You see why? Because we have cancellation property for cosine and sine and tan. So cosine inverse of x is equal to x on the left side here. Now look at the right side here. The right side, we have cosine pi over 2 minus tan inverse 5 over 12. Look at this formula here, co-function identity. If we have cosine pi over 2 minus theta, it will be sine of that theta. See, this is cosine pi over 2 minus, all this is an angle here. See, tan inverse 5 over 12, that is theta, that's angle. Unknown angle, but this is angle. The tangent of that angle is 5 over 12. So now this is what we need. X on the left side here, we have x equals sine. See, we get sine from here, from co-function. Sine of this angle here. See, that's an angle. Let's look in the next slide and see the idea. So I would say let theta be tan inverse 5 over 12. See, that is theta here. Take tan on both sides now. So tan theta will be 5 over 12. And we know the definition for tan is the opposite over the adjacent, or y over x. So this will be 5 over 12. That's tan theta. We need r, so we use x squared plus y squared is equal to r squared. So r will be 13. Now let's go back to the equation here, where we have the x. X will be sine of the theta. See, this is sine of theta. What is sine of theta? Y over r, or opposite over hypotenuse. So the final answer for this question is 5 over 13. Okay. Another very good question, little harder than example number 7, because we have pi over 6 here, not pi over 2. So we cannot use co-function, then we have to use another higher level formula. Let's solve this equation. Tan inverse 4 over 3 minus cosine inverse of x equals pi over 6. Do you remember the idea? Look at the idea. Isolate the term with x and take cosine of both sides, because it happened here also we have cosine. Sometimes we have sine inverse of x, sometimes we have tan inverse of x. It depends on the question. So we leave here cosine inverse of x, all right? And then I take this on the other side, becomes, there is a minus, you see there? And this is a plus, then you multiply with the minus, or you can take cosine inverse of x on the other side and bring pi over 6 there. Whatever you do, you will get this one here. Please check that one. Whatever you do with this equation, you will get cosine inverse of x equals tan inverse 4 over 3 minus pi over 6. Take cosine on this side, take cosine on the other side. On the left side, we have cancellation property. Look on the right side here, what will happen? Cosine, this is theta. See, this is theta minus another angle, pi over 6. This is special angle. This is not a special angle, but this is subtraction of two angles. So we can remember this formula. Cosine of A minus B. See, these are two angles. Some books, they say cosine U minus B, which is the same. Cosine of A, cosine of B plus sine of A, sine of B. So we have to use this formula, cosine of the difference. Now, on the left side, we have x here, see? So x will be cosine. Inside, we can say this is theta. I will show you on the next slide. So this is theta minus pi over 6. So let theta be tan inverse 4 over 3. See on the right side here? Let theta is equal to tan inverse 4 over 3. Take tan on both sides. Tan theta will be 4 over 3, which is y over x. So let's find r. Square root of x squared plus y squared will be 5. So sine theta will be y over r. Cosine theta will be x over r. So sine theta will be 4 over 5. Cosine theta 3 over 5. Now let's look at x. Cosine of theta minus pi over 6. Just remember the formula. I wrote it here again. So it will be cosine of the first angle theta times cosine of the second angle pi over 6 plus sine of the first times sine of the second. We know all these. Cosine of theta from here, 3 over 5. Cosine pi over 6, see that's 30 degrees, will be square root of 3 over 2. Sine of the theta, it is there 4 over 5. And sine of the 30 degrees will be half. So the answer will be 3. This is x value. 3 square root of 3 plus 4 divided by 10. Now let's look at example 9. Given the trigonometric equation, sine theta cosine theta is equal to square root of 3 over 16. Find the sum of all solutions in the interval 0 to 360. So we have to get all the angles in degrees here. Let's start. Look at the equation. Sine theta times cosine theta is equal to square root of 3 over 16. What can we do? We split the radicals. So this will be square root of 3 over square root of 16, which is 4. And multiply by 4 both sides. Then we'll get this one here. Look, 4 sine theta cosine theta equals square root of 3. Is that correct? Now here, I will leave 1, 2 outside, 1, 2 inside in the bracket. I will show you why. You can see the formula here. So the 4 becomes 2 outside, like a common factor. 2 times sine theta cosine theta. This is a complete formula for sine double angle, sine 2 theta. So this is 2 times sine 2 theta is equal to square root of 3. Remember, this is the condition here, 0 to 360. So 2 sine 2 theta is equal to square root of 3. Sine 2 theta is equal to square root of 3 divided by 2. Now that's an angle. We can say, if you remember in the other examples, we say let x. We can do that. But now we know the story. So directly we can say, what is 2 theta? This is like x. 2 theta will be 60 plus k times 360. And 2 theta will be 120 plus k times 360, where k is integer. Because sine this angle, this is x or 2 theta, it's positive. So the sine is in quadrant 1 and quadrant 2. Let's divide by 2 to get theta. We continue on the next slide. So we get the equation here for 2 theta. Divide by 2. So we get theta will be 30 degrees plus k times 180 and 60 degrees plus k times 180, where k is integer. Now let's find all the solutions from 0 to 360. As usual, we can replace k by 0 or 1 or 2 until we get all the angles in this given interval. If I put k equal to 0, this is 30 and this is 60. If I put k equals 1, that will be 210. 180 plus 30, this will be 180 plus 60, 240. If you take k equals 2 or more or less than 0, you will get angles outside this interval. So let's find the sum. So we just add 30 plus 60 plus 210 plus 240, which is 540 degrees is the sum of all the solutions between 0 and 360 degrees. Now, here we have some questions for you to practice. All the exams questions. Solve the trigonometric equation cosecant squared theta equals cotan of theta plus 3. Try. Second one, find the sum of all the solutions of this equation. Tan of x plus square root of 3 is equal to secant of x in the interval 0 to 2 pi. So we have to find all the solutions in this interval, then add them. Question number 3, find the product of all the solutions of this nice equation, sine of x times cosine of 2x minus cosine of x sine of 2x is equal to square root of 3 divided by 2 in the interval 0 to 2 pi. Question number 4, find the number of all the solutions. So you find the solutions and then you count them. Just say 1, 2, 3, 4, etc. Tan of theta over 2 minus sine of theta equal to 0 over the interval 0 to 2 pi. Solve the inverse trigonometric equation cosine inverse of x plus 2 sine inverse 3 over 5 equals pi over 2. And question number 6, solve also the inverse trig equation. Pi minus 4 arc tan of x is equal 4 pi. That's a little tricky question. Given the trig equation, 2 cosine of 3t minus 1 is equal to 0. So we need all the values of t. This is the angle here. Find all the solutions in part A without any condition. In B, find the solutions, find them in the interval 0 to 2 pi. Now here are the answers, the final answers of all these 7 questions and their parts. So for complete solution, please, you can see the video on advanced trigonometric equations, lecture number 26, pre-calculus old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture 26. I hope I can see you in another video with another topic. Thank you for listening.